All right. Hi, everybody. Welcome to the weekly report. Steve Hicks and I talked about next steps in the adventure of building a development and production hardware at Flex Radio. He's in the process of finding out how much it would cost to get a small number of development boards built by Flex. And my job is to figure out how big of an FPGA we really need. As mentioned last week, when we can get a better handle on the size required for a DVB S2X or DVB T2 design, then we can start seriously selecting and pricing FPGAs. FPGAs are expensive, and the pricing for FPGAs is kind of weird. Over the past week, there's been some good progress in finding I'd say an alternative architecture here. It's a DVB received chip that does a lot of what we would have done in an FPGA. If we do our uplink trunked, sort of like we've been talking about, and if we're able to handle all the data with the GSE, or generic stream encapsulation, in the way we've been talking about, then this chip that we're looking at may do everything that we need to receive the big downlink signal. We're now trying to find out if there's development hardware already available. Building a board just to try out this chip to see if we want to use it is expensive. So if there's already development hardware available, then we're going to go for it and get it, look at it. Right now, Steve's under NDA to look at this chip. So that's it makes it hard to talk about or give you any of the details. But this looks really good. It's not finished yet, but it's steady progress. All right, we have some good news. The NDA, or non-disclosure agreement, between AMSAT and AHA has been signed. And that means that AMSAT volunteers can work on the proprietary implementations of DVB-S2X that AHA has developed in order to get them into our payloads. The agreement with AHA is really good news and will help AMSAT achieve remarkable things. The goal of this type of work is to implement forward error correction codes from DVB-S2X into RF NOC blocks. As previously described, GNU radio blocks generally favor the general purpose processors, leaving the FPGAs and many SDRs underutilized. RF NOC, or RF network on a chip, is a way to partition the processing problem between the general purpose processor and the FPGA in a way that makes the entire radio system more efficient. We are super proud to be part of this initiative, and we hope to benefit from it long term in a lot of different ways. Another contender for building all or part of some hardware for Phase 4 is on the team. Besides being an award-winning writer and member of Phase 4 Ground, Eric Nichols, KL7AJ, also runs a company devoted to educational and scientific resources. He writes, "It has been my long-term desire to see the expansion of manufacturing in interior Alaska. Alaska Educational and Scientific Resources was created in order to facilitate the development of easy to manufacture and assemble technology products on a small scale, using the tried and true concept of youth apprenticeship. We are currently developing a number of low-cost amateur radio accessories, assembled by middle school and high school students on a part-time basis. I believe a low-cost 5 or 10 gigahertz terrestrial radio would be a great project for our fledgling enterprise, and may be the first exposure a lot of students may experience in the manufacturing process. Once a final form for the AMSAT terrestrial radio is locked in, we would like to investigate the possibility of producing these radios here in Alaska. The state of Alaska has some very attractive grants available for this kind of enterprise, and federal apprenticeship grant programs exist as well. We are currently pursuing this channel for some expansion funding. Another product we can provide is top quality documentation, both for individual devices and for AMSAT in general. With over 35 years of experience in technical writing, both for commercial and amateur publication, I am excited to see what role Alaska can play in AMSAT Phase 4 and beyond. I believe we can have a mutually beneficial professional relationship. Sincerely, Eric P. Nichols, KL7HA. Proprietor, Alaska Educational and Scientific Resources, North Pole, Alaska.
Gotta catch them all! Ha!
All right. So, Defcon Wireless Village has accepted our proposal to speak at Defcon. The conference is the first week of August. We speak Saturday from 2:30 until 2:50 in the Wireless Village. Come support us. It's a quick slot, so we're going to talk fast. We're going to release some software if all goes well, reveal some tricks, and go over the architecture and how we have approached engineering and management challenges. 15,000 people are expected at Defcon this year. While we won't reach them all, we will reach as many as we can, and we'll learn as much as possible while we're there. Okay, so we have lots of repository updates. Some of these are from last week, and then there's updates that are this week as well. So if you read the report from last week, and I know you did, then some of this will sound familiar. So there's some calculated phase noise numbers from Carrie Banke. It's in Excel spreadsheet format, and I did some visualizations, meaning I did some charts. But check it out. We need to turn these numbers into something real. Carrie's going to be doing some measurements as soon as he can. Hasn't done them yet. In other words, hasn't done them since last week. 2, we still are in a place where we need lots of volunteers to write GNU radio blocks. The main need here is that there isn't really a receiver in GNU radio. There's lots of work by Dr. MPEG on DVB transmitters. So the transmitters they're easier. Receivers are harder, but we still need help here. And that's where you guys come in. So you ever wanted to just help design a receiver or learn receiver design? This is a golden opportunity to do it. Get in touch with me. 3, on the transmitter side in GNU radio, there's some good news. Transmitter updates have not just been checked in to GNU radio, but as of today, they've been accepted by GNU radio. And this work to enhance the GNU radio blocks is because of our project. 4, on the HDL side, there's an open source receiver board project that needs some review to see if we can use it to kind of bootstrap our receiver. It's not in Verilog, which is my favorite language, it's in VHDL. The links to this project are in the notes. 5, our efforts to implement GSE or generic stream encapsulation will pay off here because we need GSE to be in this project that I just mentioned or in any project that we're going to do. Generic stream encapsulation is new with DVB version 2. So DVB S2 and DVB T2, they introduced GSE. GSE is a way to take IP traffic or Ethernet traffic or any generic data stream and frame it up and encapsulate it and get it into DVB frames. Before, DVB handled MPEG. That's it, because that's what people that buy set-top boxes want. But with the data explosion, and IP and the internet kind of being important, then being able to handle generic data became important. And that's kind of the central thing that we're using. We're relying on generic stream encapsulation to accomplish our goals here. And efforts here are going to pay off. We don't have a working implementation yet, but a lot of progress has been made, and I need some help here. So if you would like to help in this area, get in touch with me. Speaking of AMSAT, please join. If you want to contribute to Phase 4 Ground, then you can find our mailing list and all of our repository and the way to join in the links in the notes. And on to something kind of interesting about terrain profiles. I found out how to get a terrain profile in Google Earth, and it's pretty straightforward. And last week I talked about those terrain profiles. And I'm going to show the terrain profiles in this video. It turns out that Google Earth terrain profiling does not account for the curvature of the Earth. And that doesn't really matter when you're dealing with distances that are really short. But when you're dealing with distances that are over, into the, maybe tens of miles, it actually does kind of start to make a difference. And one of the Phase 4 Ground members, Mike Seguin, recommended a different tool, and it's called heywhatsthat.com. It's free as well. Google Earth is free. Hey, what's that is free. The full link is in the notes. And it does account for the curvature of the Earth, and it does line of sight. And it's kind of, instead of just being a terrain profiling app, it actually is more intended for the things that we're doing. So he uses it for 24 gigahertz, and he did a bunch of really good work to check out the profiles that we have for San Diego. Anyway, I'm including them here, and we really appreciate it. This is a good tool in the toolbox. Okay, more soon. Got to catch them all.